Hi guys, it's Mrs. Moss here, and we're going to move on with metamorphic rocks next. You remember sedimentary rocks are formed from the compaction and cementation of sediments, and igneous rocks are formed from the solidification of magma or lava. Well, metamorphic rocks come from the Latin terms meta, which means change, and morph, which means form. So metamorphic literally means change form. So how are metamorphic rocks formed? Well, they're actually formed from igneous rocks and from sedimentary rocks that undergo tremendous heat and pressure, and it changes the rock into a metamorphic rock. So here we have igneous granite. Under heat and pressure, it becomes metamorphic gneiss or gneiss, depending on who you are and how you say it. Sedimentary and conglomerate, which has the rounded particles that we looked at just the other day, when it's subjected to tremendous heat and pressure, it becomes metamorphic metaconglomerate. And you can see actually the particles are still there. They've just actually flattened out, almost like a panini press. It just really just flattened out the particles. It's pretty cool. So let's talk about the formation of metamorphic rocks. Well, as we said, metamorphic rocks are from pre-existing rocks that have undergone changes. These pre-existing rocks are altered because they're subjected to a tremendous amount of heat and pressure. And during this process of metamorphism, the rock doesn't melt. We sometimes get that idea in our minds that the rock is melting and turning into another rock. It actually does not melt. It remains a solid. If the rock did melt and cool, it would become an igneous rock. So it's not a melting process. It's a recrystallization. So the extreme conditions of the heat and pressure cause the minerals, as I said, to recrystallize. And that recrystallization allows the mineral crystals to grow larger and become even new minerals that may crystallize. In addition, the newly formed rocks are less porous and more dense than the parent rock. There are two textures that we need to be aware of when we talk about metamorphic rocks. Here we have foliation as the first type. Foliation is when the mineral crystals are aligned in parallel layers. And you can see at the bottom of the screen there's a diagram that shows randomly oriented minerals before pressure is applied. That's on the left-hand side right here. Once we have the heat and pressure, it allows the minerals, as you can see, to line up. And what that looks like in real life is something. Right here we have the before and after shots of metamorphic rock. If you look here, the minerals aligned and we can see it almost like stripes in the rock. That is the biggest indication that we're looking at a metamorphic rock, if it has the foliation. Here's another diagram that demonstrates what I'm talking about. Before metamorphism, we have the randomly placed minerals, as in this picture down here of a granite. And then the picture on the right, we have the lines that have, the minerals that have undergone heat and pressure lining up, and it makes a stripe or a foliated texture in the metamorphic rock gneiss. There's another type of rock, another type of texture that goes under what we consider foliation, and that's known as banding. And this is when the minerals that are in a line actually make black and white or light and dark bands of color based on its density. When we see that type of foliation, we call it banding. Okay, and this rock picture is an example of what I'm talking about. You can see the black and white stripes that are really light and dark colors based on its density when the minerals aligned. We also have non-foliated texture. It is the absence of mineral alignment. So you'll see, we'll show you some pictures of what that looks like as well. Here's a picture of heat and pressure that is placed on the one rock and it creates a foliation, and then another picture, the same heat and pressure is applied, it creates banding within the metamorphic rock. Another picture of schist, which shows banding. black and white, dark and light colors. Again, we have gneiss, another banding, shows black and white colors in the mineral alignment. And here is another example of non-foliated versus foliated. So this would be also considered, excuse me, a metamorphic rock. However, there is no foliation. Whereas on the right, we see the foliated stripes indicating the change that has occurred with the mineral alignment. So there are two different types of metamorphism. First, we'll look at regional metamorphism. Regional metamorphism occurs over a large geographic area, and it's under extreme conditions of heat and pressure. It usually occurs at great depths. Okay, so what you need to recognize here is this is occurring over a very large space, as in mountains, and it really to mountain building events that cause the heat and pressure of the rocks that are being moved and forced upwards. That pressure and that heat that's generated from the land processes that make building mountains creates metamorphism in that area. So I'm just going to go back because I skipped through those pictures, but here is an example of regional metamorphism along the Appalachian Mountains. Anytime you see a mountain range, you would expect to see regional metamorphism. And going back to this picture, this is an example of what occurs with the layers of sandstone. You can see the different layers. It has been pushed together from land formation processes, and it's creating heat and pressure as it's building up and up and up. And that's where you'll see the metamorphic rocks. Okay. They're also highly folded and exhibit distorted structure. So you will actually see waves or swirls in these rocks. Really cool. Here's the rocks that are produced by regional metamorphism are subject to such extreme temperatures and pressure that they're usually foliated too. So again, you see the striping that occurs, and you'll see swirls too. It's very neat. Here's an example of what I'm talking about. This is a chunk of metamorphic rock that had undergone regional metamorphism. Another example of regional metamorphism with all the foliation, and you see the swirls or the distortion that occurred within the rock because of the. So here's the second type of metamorphism, and it's called contact metamorphism. Now this does not occur over a large area. This occurs in one specific location within the earth. And this occurs where molten magma or lava comes in contact with a pre-existing rock, and it heats them. It doesn't melt them because, as I said before, if it melted it and hardened, it would have turned into an igneous rock. So it just heats it up enough where the crystals can change and minerals change, and it creates a new rock. So because of the contact metamorphism, it usually only involves heat, not as much pressure. The rocks formed are usually non-foliated. So this diagram shows an igneous intrusion that has come up through the layers of sedimentary rock that were there before. Now, if you look, you see this, if you look over in this area, this is where the magma has come up through the rock. It pushes its way through the layers of sedimentary rock. We call that an igneous intrusion, as I mentioned. See the lines that are coming out? It looks like little hairs coming out of the igneous intrusion. That's the exact spot where we will find metamorphic rock, because right where that magma touched that rock layer, we will have contact metamorphism occurring. It doesn't change the entire layer of rock that's there. It'll change just the spot that it touches. So that way we have a line of a metamorphic rock that will surround that igneous intrusion. Excuse me, this is another example of how we see undisturbed sedimentary rock layers on the left-hand side of the screen. And we see an igneous intrusion coming, and it's actually changing the area right around it, just where it's touched. So in this location, we have metamorphic rock gneiss, we have marble that's changed from the limestone, and we have sandstone that has changed into quartzite, a metamorphic rock, all from the heat coming from that igneous intrusion. And as it touches and grows along the way, it will continue to change the layers of rock that it touches. And we're going to summarize everything for you right now. I'm going to just quickly go through so you can see this and you can copy it down. You're going to have to hit pause and fill in the blanks as you go. Metamorphic rock forms from pre-existing rocks that have been altered by heat and pressure. Rocks never melt. Because of the intense heat and pressure, the rocks recrystallize. The minerals grow larger and new ones may form. The rocks may also exhibit foliation or banding, parallel or mineral alignment. The rocks also become more dense and resistant. Two types of metamorphism are regional and contact. Regional metamorphism occurs over a very large geographic area, like in a mountain range, and contact metamorphism occurs between the interface where hot magma touches a pre-existing rock. There is no pressure, only heat. Any type of rock, igneous, sedimentary, and more metamorphic, can undergo recrystallization to create a new metamorphic rock. Limestone metamorphoses to become marble. When sandstone is under metamorphosis, it becomes quartzite. The parent rock of slate is shale. So why, we ask, would you not find any fossils in metamorphic rocks? Well, fossils would be destroyed because of the tremendous heat and pressure that metamorphic rocks undergo. So that's all for now. We're going to end it here, and tomorrow we're going to look at the reference table and metamorphic rock chart, and we're going to see how we can use that to help us identify rocks. That's all for now. See you next time.